We're going to take a look at question number 10 now. This is the volume of a cone, and they give you the volume formula for this specific cone because they say there's a relationship between the radius and the height, so they've replaced where h would go in the formula with this 10 minus r. They did that for you. You don't need to do anything special there. They also tell you that the dr dt, the rate of change of the radius with respect to time, is 6. So we'll use that as a substitution in a bit. They want the rate of change of the volume of the cone with respect to time. So I'm going to take the formula that they gave us, and I'm going to distribute the 1/3 pi r squared to that 10 minus r factor. And I wind up with this. And I'm doing that just to make the derivative easier. Now I take the derivative of everything with respect to time, and we wind up with this. And you can stop the video and look over that just to make sure that you're okay with that. Remember, every time there's an r derivative, you have to multiply by dr dt. Now they told us dr dt was equal to 6, so I'm going to do those substitutions, clean this up a little bit, and when I do that, I wind up with 40 pi r minus 6 pi r squared, which is of course a match to choice E. All right, on to question 11. Here we go. The bane of our students' existence here, the related rates questions with shadow, the person walking away or towards a lamppost. They're really not that bad, all right? What you have to do is draw the triangle, the right triangle, to represent the situation here. So I'm going to do that. There's our person, there's the lamppost, and it creates two smaller triangles. Now, just to be clear here, that distance from the person to the tip of the triangle, we're going to call that x. That's the length of the shadow. And the distance from the person to the lamppost, we're calling y. Right? That's the distance simply from the person to the lamppost. So we have two similar right triangles here. We have a smaller one in red, and then we have a bigger one in green. They are similar because of angle. They share that angle at the tip of the shadow, and they share the right angle. Okay, so having said that, I can now use the fact that similar triangles have corresponding sides that are proportional. So from the smaller triangle, I'm going to do the horizontal leg of x over the person's height, which is 6. And from the bigger triangle, the horizontal leg is going to be x plus y over the height of the lamppost, which is 15. And I'm going to wind up with that. I'm going to cross multiply to get this. I'll combine my x terms by subtracting 6x from each side. And now I'll do the derivative. Everywhere there's a variable, I have to multiply by the dx dt for x, dy dt for y. Now they told us the person is walking away from the base of the streetlight at a rate of 4 feet per second. That's the y distance they're talking about, or specifically the rate of change of y, dy dt. And since they're walking away from the lamppost, that's positive. That's going up. It's increasing. If they were walking towards the lamppost, you'd have to write that as a -4. So we do that substitution, divide both sides by 9, and we wind up with 24 over 9, or approximately 2.667, rounded off, which is a match to choice B. All right, that was question 11. Question number 12. This is a tricky one, and I need to warn you, because of that calculator icon right there, it definitely is something that could trick students into thinking that they just put this in y1 and they use x instead of s, and then they can use math 8 on their calculator and take a derivative of this. But it's not that simple. Look at what they're asking for. They want to know if the car is traveling at 50 miles per hour and its speed is changing at a rate of 20 miles per hour squared. At what rate is the fuel consumption changing? So they're giving you not just the speed s, but they're giving you the derivative of s, the rate of change, and that's the 20 miles per hour squared. They're giving you ds dt. So this is really like a related rates question, all right? So when you take the derivative here, right? The derivative of an exponential function is the exponential function itself times the derivative of the exponent and then times the natural log of the base. That's how you differentiate an exponential function. Now, because the base is e, the natural log of e is just equal to 1. We don't need to do that. But if you look carefully at what I've written here, you've got the original exponential function first, and then it's multiplying the derivative of the exponent. And notice something about the derivative of the exponent. Every time we differentiate a term with s, we multiply by ds dt. Just like in any implicit differentiation question and any other related rates questions. It works the same exact way. All right, s is 50 and ds dt is 20. So I do all of those substitutions, and you can work this out. Just go carefully on your calculator. You're going to wind up with that 4.299 miles per gallon per hour, and that is a match to choice B. Okay. On to question 13. Another shadow question. So this is very, very similar to what we just did. So I'm going to kind of move through this a little bit quickly. You can read the question at your own pace, but I'm going to set up my similar right triangles. This time the person is 2 meters tall, and the lamp post or street light is 8 meters tall. X is the length of the shadow, just like before. Y is the distance from the person to the street light. Now, it does say the person is walking, and it says the shadow is lengthening. So for the shadow to be lengthening, the person has to be walking away from the lamppost. So that means that Y is getting bigger over time. That was the tricky part of the question. Anyway, there's our similar triangles and our proportional sides equation. Same step as before, we cross multiply, get the x's together by subtracting 2x from each side, and now we differentiate everything with respect to time. We happen to know what dx dt is. That's the 4/9 meters per second, so I can substitute that in. And when I solve for dy dt, I wind up with 12/9, which simplifies to 4/3, which is answer choice D. All right, we'll take a look at the next group of questions in the next video.